Welcome to the world of fighter jets, where cutting-edge technology meets high-flying adventure. Get ready to explore the mind-blowing capabilities of these incredible aircraft, packed with advanced electronic systems that make them true marvels of engineering. From the mighty F-35, a flying data center that processes a vast amount of critical information, to the jet engines that keep it all cool, we will unravel the secrets behind these awe-inspiring machines. But the excitement doesn't stop there. We'll delve into the latest upgrades, from Block 4 innovations to groundbreaking adaptive engines. Are you ready? Take a deep breath. Strap in, prepare for takeoff, as we soar into the astonishing dominion of the fighter jet. Where to begin? These incredible aircraft are packed with advanced electronic systems, especially in the latest generations like the 4th and the 5th. One of the most impressive 5th generation fighters is the mighty F-35, which is like a flying data center. It handles an incredible amount of information to perform sensor fusion, a vital task for its operations. Now, all this high-tech wizardry generates a massive amount of heat. Imagine the cooling requirements for these electronic systems. It's through the roof. But fear not, because the jet engines come to the rescue. They play a crucial role in keeping the aircraft's electronics cool. How do they do it? Well, they extract compressed air and pass it through heat exchangers, which helps transfer the heat away from those sensitive electronics. The diverted airflow is called bleed air, and it is an essential component of jet engine design, especially for 5th generation fighters like the F-35, which is designed to serve well into the 2070s and is continually being upgraded to stay at the top of its game. These upgrades come in what they call blocks. So far, they've had blocks 1, 2, and 3, but the latest and greatest is block 4. This upgrade is a game changer, bringing a plethora of improvements, including significantly more computing power, processing power, and memory compared to its predecessors. As you can imagine, these advanced electronics demand even more cooling capability. That's where the engine steps up to meet this challenge. Initially, the F-35's engines, Lightning's F-135 engine, was designed with 15 kilowatts of bleed air extraction to support the cooling requirements. Pratt & Whitney, the company behind the F-135 engine, even built in extra margin for future growth. But here's the twist: the cooling requirements have skyrocketed since then. The Joint Program Office, responsible for the F-35's development and sustainment, has stated that the current engine's cooling capacity is far from adequate to support the Block 4 package. And guess what? They're already working on Block 5, which will demand even more cooling power, about 20 to 30% more than Block 4. Even for Block 3 Lightning, the engines had to run hotter for longer periods than originally intended, and this has resulted in higher maintenance costs and reduced lifespans for the engines. But fret not. Pratt & Whitney have come up with a brilliant solution: the engine core upgrade. These upgrades can be applied to existing and future F-135 engines, which power all 3 F-35 variants: the Air Force's A model, the Marine Stovall B model, and the Navy's carrier-based C model. This ECU upgrade is like giving the engine a superhero boost, making sure it can handle all that extra cooling power with ease. So, the F-35 is geared up for an even brighter future with its continuous upgrades. It's like an aircraft that keeps getting better and better, always staying at the forefront of technology. These improvements will ensure the F-35 remains a formidable force in the skies, ready to tackle any challenge that comes its way. But let's dig a little deeper. Pratt & Whitney's ECU is designed to work with extra power and thermal management upgrades, called PTMs, but guess what? There's more exciting news. Collins Aerospace, a division of Raytheon and the parent company of Pratt & Whitney, is also developing an improved cooling system called EPACs. When you combine ECU, PTMs, and EPACs, the F-35 will have a massive 80 kilowatts of cooling power. That's more than enough to meet the cooling needs for the entire F-35 program, even with the upcoming Block 5 upgrades and beyond. Now, here's where things get really interesting. The Air Force is exploring a new engine option for the F-35 under the Adaptive Engine Transition Program, or the AETP. These engines are like shapeshifters. They can switch between high performance and high efficiency modes depending on what is needed. General Electric has its prototype called the XA100, and Pratt & Whitney have their version, the XA101. These adaptive engines have the potential to boost the F-35 speed by 20% and increase its range by a whopping 30%. Plus, they offer double the thermal management capabilities, making it a powerful upgrade indeed. However, while these adaptive engines seem like a perfect match for the F-35, there are some significant challenges to consider. Firstly, having two different engine designs from different manufacturers would make maintenance and finding spare parts tricky, to say the least. Additionally, the XA100 and the XA101 engines were designed to fit the Air Force's F-35A variant, and they would likely fit the Navy's F-35C variant too. But here's the rub. Fitting them into the Marine Corps' F-35B variant, which uses short takeoff and vertical landing capabilities, would require significant modifications. There's even some doubt whether an adaptive engine would fit the F-35B at all. So, it's not just about upgrading the engines, there's a whole new layer of maintenance and support to consider, not to mention the cooling challenges already faced by the current engines. Let's break it down. If an adaptive engine cannot be designed for the F-35B, then it might be stuck with a Block 3 upgrade for its entire lifespan. Nevertheless, the GE XA100 introduces some exciting engine competition, just as the F-35 reaches what many see as the midpoint of its production run. With several NATO countries choosing the F-35 as their fighter and over 900 examples built so far, this aircraft has many years of production and ongoing support ahead. So the future of the F-35 is full of possibility, and the decisions about its engines will play a significant role in shaping its path ahead. And with so many new models being made and ongoing support needed, the F-35's production line will be busy for years to come. There's no doubt that the adaptive engines from companies like GE and Pratt & Whitney could be beneficial for the F-35. They offer exciting improvements. However, there are some challenges to consider. These engines have very high upfront costs and ongoing maintenance requirements that might outweigh the benefits they bring. So, for now, Congress seems to be leaning toward Pratt & Whitney's ECU upgrades for the existing F-135 engines. According to Raytheon, these upgrades will cost around $2 billion, but will save an incredible $40 billion over the F-35's lifetime. Now that is a fantastic deal, rendering other options somewhat superfluous. But don't worry, the adaptive engine program is still alive and kicking. It's highly likely that these new generation engines will be used in the next generation air dominance, or the NGAD fighter. The Air Force has plans to use the knowledge gained from its efforts with the Adaptive Engine Transition Program, or the ATP, in the Next Generation Adaptive Propulsion Program. It's fascinating to see the Air Force using NGAP to expand the US jet engine industrial base beyond the current players, Pratt & Whitney and GE. In fact, contracts have been awarded to companies like Lockheed Martin, Northrop Grumman, and Boeing, all of which haven't historically been involved in jet engine manufacturing. It looks like they're aiming to diversify and grow. In conclusion, the F-35's journey is full of excitement and promise and possibility. With the upcoming Block 4 version, the F-35 is poised to redefine fifth-generation fighter design, continuously pushing the boundaries of aviation technology until Block 5's arrival. The adaptive engines and ongoing advancements promise even more remarkable developments, ensuring that the F-35 remains an uncompromising and indomitable force for years to come. As you can see, The sky is the limit. So, are you with Team Pratt & Whitney's ECU upgrades? Or do you think the adaptive engine is better? We would like to hear your thoughts and opinions in the comments section below. And don't forget to like and subscribe to our channels for more exciting updates about the jets. Hit the notification button to stay tuned, and thank you for watching.